Okay, again, good afternoon to all. I'm very glad that we all are here and we have the opportunity to discuss ideas that can make our world better and our environment, and they can help our environment. This gives us hope and optimism for the future. I'll welcome you both. Mr. Edson, he is co-founder and Chief Technology Officer from Ocean Diagnostics, and Mrs. Elia Nikitopoulou, External Affairs Officer from Blue Cycle. So is it better, I think, to begin with Mr. Edson? Can you hear me?
Yes, yeah, I can hear you just fine. Can you hear me okay?
Just a short presentation of your work.
Yes, great. Just 1 second here. The slides work.
Explain to us what is Ocean Diagnostics.
Great. Thank you so much to the organizers of today's event for having me. This is really great to be on this forum, and it's really great to hear some of the speakers that came before me. And I think the last talk was a good segue into what I'm going to be talking about, which is our company, Ocean Diagnostics, and technology that we're creating in order to help monitor and detect microplastic pollution in the marine environment. Are you guys able to see my slides okay? Sorry. Hoping you guys can see my slides. Great, so who we are. Great, so Ocean Diagnostics, we are an environmental impact company. We're based on the west coast of Canada in British Columbia. And our company was founded by scientists and engineers, and we are trying to create new technologies in order to quantify plastic pollution and biodiversity loss in the marine environment. So we work with many different partners, including academia, governments, industry, foundations, and pretty much anyone to better detect microplastic pollution and influence informed decision making. So as we know from today, the problem with plastic pollution is that basically it fragments into much smaller particles. So larger pieces of plastic that can start as like the chairs and the plastic bags and all of the things. Basically everything breaks down into these much smaller particles. So we have pre-production nurdles, we have tire wear that's coming off of tires from cars on the street, fibers coming from synthetic textiles that are coming from laundry and sort of wastewater discharge. And then larger pieces of plastic are fragmenting into smaller pieces, including fragments, foams, and films that are coming from plastic bags. So once these are in the environment, they're very difficult to control. And they continue to just fragment into smaller and smaller particles. So this presents a real challenge for us in terms of environmental impacts and how we can kind of mitigate the effects of these particles on the marine environment. So what do we see as the solution? We break it into kind of 3 parts. And what we see is that first we need to establish baselines. We need to understand what are the different levels of microplastics and what are the sources and the impact and transport and fate of those particles. How are they getting into the environment and what are the levels now? And then as we've talked a lot about today, we need to then kind of use that information and interpret that information to understand what the sources are and try and create change upstream. So this would be plastic bag bans and reducing kind of the discharge of single-use plastics into the environment. And really, going at this from a policy level and creating kind of change upstream that will hopefully have a positive effect later on downstream. And the only real way to understand if those upstream solutions are having a positive impact is to put in place kind of monitoring networks where we can have sort of time series data in the marine environment, looking at the levels of microplastics to understand if the things that we're doing on the policy end are having a positive effect on the actual levels of microplastics that we're seeing in the ocean. And then this kind of repeats. We establish baselines, we use that information to create new policies over time. And so in this loop, we really see this as the way to kind of understand the discharge of plastics and try and make sure that we're doing things upstream that are helping the overall levels. So our strategy at Ocean Diagnostics is to come at this from many different ways. We develop new technologies to help quantify microplastic pollution as well as biodiversity loss in the marine environment. We work with lots of different collaborators and partners to get people on the ground that are actually out there and doing sampling and collecting this data. We've built a centralized, standardized laboratory for analyzing microplastic particles, which is something that I think is really needed. There's lots of great academic institutions that are analyzing particles and in more kind of academic ways, but there don't exist many commercial places where samples can be sent for kind of rigorous standardized analysis. And then last but not least, there are not enough scientists in the world to collect the amount of data that we need to make change. So we're really leaning into using community science, or citizen science, to kind of deploy the tools that we're creating and getting way more people on the ground to help us collect and interpret this data. So just going through some of the technologies that we develop. The first one is basically a depth device, which allows us to collect microplastic samples at depth. So there's different tools for collecting microplastics at the surface, but up until now, it's been very difficult to collect microplastic samples below the surface of the water in a way that prevents contamination and makes it easy to deploy without needing a large research vessel or a large piece of equipment in order to collect those samples. So we've designed a small portable filtration device that you can drop down to 400 meters and collect filtered samples in a really easy, standardized way. And these filters can be sent back to us at the lab for analysis. And we can give kind of a full chemical characterization, a physical characterization of the particles that are present on these filters. And this really allows us to get a three-dimensional view of microplastic pollution, let's say in the Mediterranean basin. So rather than just looking at the sea surface and looking at the basically in the sediment, we really want to know what's going on in the water column so we can understand how these microplastics are affecting and interacting with the commercially important species that are kind of in the middle of the water column. Another device that we've developed is called Saturna, and this is basically a community science tool or a research tool that we've developed to make it much easier to quantify the sort of physical parameters of microplastic particles that are collected. So maybe in a beach study where particles are collected from the sand, or in surface water sampling like manta trawls or Newstone nets, particles are collected from the environment. And up until now, it's been very difficult to count and quantify the physical dimensions of these particles. So what we've done is we've developed this standardized camera system where you can place particles onto a background sheet. And then we use a series of computer vision algorithms to quantify the size metrics of these particles. And this gives us a good sense of the color and the total size of the particles, and gives us some more information about kind of maybe where these particles came from. And this is all done in a more standardized way. So we're trying to release a lot of these tools to community science groups to start getting more analytical information about the particles that they're collecting during their sampling. Going back to community science, in addition to the Saturna tool, we've also developed a series of beach sampling protocols that involve basically 100-meter transect and collecting microplastic particles in a very standardized way using quadrats and sieves. And along with this, we've created kind of educational resources. So our goal with this is to get lots of different schools along the coast out there onto sandy beaches, collecting kind of routine monitoring data on the levels of microplastics on their local beaches. And using our protocol and our kit and the Saturna tool that I just mentioned, we're hoping to kind of use schools and other volunteer groups and beach cleanup groups to try and increase the community science that's happening in the basin. And last, we have laboratory capabilities. So we're creating this standardized lab, as I mentioned before, that can accept commercial samples. And this is really important for kind of the standardization of microplastics analysis in this organization, right? So rather than having different academic groups that are analyzing particles in different ways, we've created a standardized lab where we can accept samples from many different places and analyze them in a standardized way. And this allows us to, sorry, I'm just gonna put this. Are you guys able to hear this a little bit better? Sorry about the technical feedback.
Can you please continue through your mobile and not through your laptop?
Okay, we reconnect with Mr. Edson. We have an idea, not the whole idea, but I suppose we communicate with him later. Maybe Mrs. Nikitopoulou, maybe you can present us your work and what are you doing in your company. So this will give us time to move on. Mr. Edson, we'll come back to you later with a better connection. Okay. So, Mrs. Nikitopoulou, what does Blue Cycle does? So, can you tell us, can you present us?
Yes, of
yes,
course.
We need time to change.
First of all, thank you. I would like to take the opportunity to thank the organizers for inviting us. Blue Cycle is actually a startup company. It was established in the summer of 2019, but we had all these COVID adversities to face. It was quite a stressful time. But the idea was to try to tackle the problem of fishing litter coming from the fishing and shipping activities. So the numbers are quite interesting. The fishing gear into the sea is the 30% of the marine plastic in the EU, and only 1.5% is recycled. Mm-hmm. So the numbers are very stressful. Blue Cycle decided to find a solution with an holistic approach. So we are doing the collection, the processing, and the production of a final product coming from the plastic waste from the fishing and shipping activities. So we collect fishing nets, fishing lines, mooring ropes and ropes from our main sources, which are collection points we have established throughout Greece. We have other marine litter collection points from Generic Breath, an NGO organization we are cooperating in this part. Mm-hmm. And in Greece, we have big manufacturers and industries producing fishing ropes, fishing nets and mooring ropes. So we collect their wastage. And of course, aquacultures and mussel farms in Greece, a big industry, with they do need to change their equipment quite in a certain amount of time. So all this all this equipment, the best it could be done with it is to end in a landfill. Blue Cycle gave a solution implementing a circular economy idea. So after the collection, we have collection points in various parts of Greece, and this network getting bigger and bigger by the actually by the day. We have collected at Athens now 530,000 kilograms of fishing and I would like this photo is a photo of a ghost net at Salamina. We made the underwater cleanup together with the January breath, and we have collected also, and we are collecting ghost nets. Ghost nets is #1 factor for the death of marine animals. So, in order to produce the material, raw material, recycled plastic material of high quality, the most important thing is the separation of this material. It is important to separate it not only as a post-consumer or pre-consumer material, so if it's a factory wastage or not, but it's important to separate it by polymer. So we know that the polymers used for the fishing and shipping activities are certain types, polypropylene, polyethylene, nylon 6, and polyester. So we have to separate it very carefully and then recycle it mechanically by type. So this process of separation is quite important. These are the types of polymer we are collecting, the types of the fishing and shipping material. And then when we are speaking about post-consumer material, we know that there is there are some pollutants. We have to clean it. So the material, the raw material, then it is of high quality. We have a zero discharge system for cleaning this material, and then do the extrusion and all the other processing in our lab in Piraeus, which is a zero waste lab, because everything we produce we can recycle. So all our products are 100% recyclable. And also we are hosting the first and only in Greece robotic large-scale 3D printing lab. And we are open to R&D. We are doing R&D processes, but also we are open to everybody who would like to test and the material. And the idea is also that everything we are doing is traceable. So our material is 100% traceable. So everything that comes into our storage in our warehouses, we are registering. We have made an application for us internally, so we know where is it from, and then after the processing, we also can assure everybody that takes our material that this came from this source and the things that have happened to. And now our products. First of all is the pellet, the recycled plastic pellets in the middle, which are of high quality and they can be returned to the plastics industry. This is the, let's say, the circular economy 100%. But also we have the opportunity in our laboratory to create other products that can be everything, as I said, traceable and recyclable, that new products that can be used and spread the message that the plastic from the sea can be transformed into something that has added value. So these are our Jenga tiles. And we also have a production line for 3D printing filament from nylon 6. So we can extrude the material. This photograph is absolutely the idea. We take these yellow fishing nets we find in every Greek island in the summer. We are recycling them, and we can produce 3D printer filament for all 3D printers to use. I'm sorry. Okay, and some tiles coming from mussel farming nets, mussel farming socks they are called. For example, the mussel farming socks you can see in the image are collected from northern Greece. They were a major pollutant factor at the Axios Delta. So we have collected together with IC and created a lot of items, and now our robotic large-scale 3D printing lab can produce from this material furniture and design items. These are also 100% recycled by Blue Cycle. So we have some, we have also some pilot R&D projects for the production of a yarn for clothes or other things, and also for construction, as a construction material, which is a big project R&D. We are working with all stakeholders. This is the key. Blue Cycle depends on synergies. We are open to synergies not only for the collection of our material, but also to spread the message and to have an impact in the decision making, which can be vital for not only for coastline places, but for all Greece. So we go to the source. We have our principles. We are very adamant in that in these principles. So we have we have been working all these years, a few years, but we have working constantly with all stakeholders, and we would like to expand our project, our program. The proof of concept has been done. Now we are ready to scale up and to move into larger productions and be more efficient. And these are a few of our partners, and we're very happy to have them on board.
So great, impressive numbers and great work. And I would like to ask you something about the cost of the products. Does collecting and recycling the material increases the cost, and does this prevent people from buying your products, or it sounds appealing, the fact that it's good for the environment and it's...
Actually, it's both of the statements are accurate. It increases the cost. The transportation is a big issue. We want to have a very low carbon footprint, so we do our best on that point. And also we are, but all this processing, it raises the cost of production. But our customers are, let's say, our friends are very happy buying something that comes from a very clear and very transparent procedure. So that goes both ways.
Okay. So we will reconnect with Mr. Edson, or okay. So we.
Are you able to hear me?
Yes, I would like to make you just one question because we're running out of time. Mr. Edson, is this mechanism, instruments or requirements enough to have the big picture about what is happening now in our oceans and how can we use this data to find a solution? Who is interested in the government, organization, companies? Does they want to solve the problem actually?
Yeah, that's a great question. So it's really important, again, for us to kind of use this data, I think, for long-term monitoring. So as we put basically policy into place, we really need to set up monitoring networks and use technology to quantify microplastics in the environment so that as we put these policies into place, we can ensure that they're having a net positive impact on the downstream environment. So using that data, I think, is really important for quantifying policy action.
Okay, thank you both very much. We are run out of time. Thank you so much, and good luck to your plans for the future. Thank you all.
Thank you.
Thank you.